I am Anil Kumar sharing with you questions from previous test paper. I hope this will help you to prepare for your own test. We have a variety of questions here in this test paper. First, we need to evaluate logarithms using laws of logarithms. Then we have equations to solve. And then we have log of log function to work with. And here we have logarithms with different bases, right? So change of base will be the formula which you need to apply to solve question number 4 and 5. I'd like you to pause the video, copy the questions, find the answers, and then look into my suggestions and solutions. I hope you remember change of base formula, which is if the base is given to us as log a of x and we want to change the base to b, we could always write this as log b of x over log b of a, right? You would also change the base to 10, for example. So you could write this as log of x over log of a when you change the base to 10, correct? You could change the base to anything you like. So with that, I shall now begin to solve these questions one by one. I hope you have already copied these questions. This test is without calculator, right? So let me write down here. It is without calculator. So especially for IB students, you do have a test paper where calculator is not allowed. This could be one of those kinds. So we'll begin with very simple question, that is to evaluate using logarithmic laws. So whenever you have take away, that means division, that is multiplication, right? And this is power. So these are the three laws being used. The first one here is log to the base 5 of 40 minus log to the base 5 of 8. We could write this as log to the base 5 of 40 over 8, right? So that is C law. So we just divide these numbers. So what we get here is log to the base 5 of 40 divided by 8 is 5, and log 5 of 5, is 1, right? The next one here is log to the base of 4, right? And the number here is 256. So we have 256 to the power of 1 over 3. So that becomes the power. So applying the logarithmic laws, you could write this as 1 over 3 log to the base 4 of 256, right? Now the idea is to write 256 as power of 4, right? So what we can do is just try it out. So 4 times 4 is 16. 16 times 4 is 64. And 64 times 4, we could do like this, right? So 64 times 4, 4, 4, 16, 6, 1, 24, 256. Do you see that? So 4 to the power of 4 is 256. Therefore, I could write 256 as 4 to the power of 4. Now, it is 1 over 3. That was the power law. And again, 4 to the power of 4, I could take 4 outside. So it becomes times 4, log 4 of 4, right? And log 4 of 4 is 1. And therefore, what I get here is 4 over 3 as my answer. Correct? The next one here is product rule for logarithms. Log to the base 20, just multiply 4 by 5, and you do get log to the base 20 of 20, which again is 1, correct? So that's how we could do the very first question. Let's move on. Question number 2 here is, we need to solve these two equations. The first one here is 8 times 3 to the power of x equals to 216. And then we have log of 4x minus 1 equals to log of 4x plus 1 plus log of 2. Now, to solve such equations, we could write this as 3 to the power of x is 216 divided by 8. Now, 8 times 2 is 16, 56, 8 times 7. So we have 3 to the power of x is 3 to the power of 3. 3 cube is 27, and that gives you x equals to 3. So strictly speaking, this is just an exponential equation. The next one here we could bring these terms together. We have log of 4x minus 1 minus log of x plus 1 equals to log of 2. Applying the log rules, so that means division, so it becomes 4x minus 1 over x plus 1 equals to log of 2, right? So now two logs are equal. That means 4x minus 1 over x plus 1 should be equal to 2, right? Cross multiply and solve for x. 2 times x plus 1, which could be written as 2x plus 2. Get the terms together. 4x minus 2x equals to 2 plus 1. So we get 2x equals to 3, or x is equals to 3 over 2, right? Now, once you get your answer, you should check for it, right? Is this a valid answer? Now, if you look into the restrictions here, we know for the first one here, log of x plus 1, log of x plus 1, x should be greater than minus 1. In this case, x should be greater than 1 over 4, right? So basically, we are looking for something greater than 1 over 4, and this definitely is greater than 1 over 4. So it works, correct? So it works. So it is actually 6 over 4, right? So it is okay. So that becomes the solution. We could have extraneous roots. So keep that in mind. These questions, this one doesn't have. Okay, so let's move on. Now we have a very interesting question, which is log to the base 2 of log to the base 3 of a equals to 2. You need to determine the value of a, right? Now, let me rewrite this question. We are saying log to the base 2 of log to the base 3 of a is equals to 2. That really means that 2 to the power of 2 should be equal to inside, which is log to the base 3 of a, right? Should be 2 to the power of 2. So we could write this as log to the base 3 of a is equals to 4. And so what is a equals to? Write it as exponential form. We get 3 to the power of 4. And so we get our answer. A is equals to 9 times 9, 81. Correct? So that's easy. So I hope there is no difficulty in solving these problems right now. So you can now copy this question. This is kind of tricky. Work it out and then I'll provide you the solution. So the question here is, we need to solve log to the base 2 of x plus log to the base 3 of x equals to log to the base 5 of x. So let's change the base first thing, right? Let's say have the same base, change the base to 10. So we could write the equation here as log to the base of 10 of x over log to the base 10 of 2. Is it okay? Plus, this could be written as log to the base of 10 of x, correct? Denominator will be log to the base 10 of 3. And on the right side, we get log to the base of 10 with x is log to the base of 10. So we have changed the base to same base. That is the first thing to do. Now we can bring all the terms together. We get log of x over log of 2 plus log of x over log of 3 minus log of x over log of 5 equals to 0. You can take log of x common, right? So we could write this as log of x. Within brackets, we have 1 over log of 2 plus 1 over log of 3 minus 1 over log of 5 equals to 0, right? Now these are numbers. Log of 2, log of 3 and log of 5 are numbers, correct? And we know the center portion here, I mean the other factor is not equal to 0, right? However, this could be equal to 0, right? So we do have a solution here, and the solution is that log to the base of 10 of x is equal to 0. And that gives us x is equals to 10 to the power of 0, which is indeed 1. So x equals to 1 becomes the answer, correct? So that is the solution for the given equation. And of course, if I write x equals to 1, we get 0 plus 0 equals to 0, correct? So that's kind of important to understand. Now this could be a multiple choice question at times. So now you know the answer is 1. Okay. The next one here is we have reciprocal of logs. So this is also a very interesting question. Here is the last question of the series. We need to solve 3 over log of 2x plus 2 over log of 3x equals to 1. As you notice, log is given in the denominator. Can we write this as reciprocal of something? That is what we'll see now. If I say that log of ax, I want to change this base. And if I change the base to x, then what happens? See, then I could write this as log of x over log of x of a. Do you see that? Now the numerator here is just 1. So I could write this as 1 over log of xa. Now see carefully. We are writing log to the base a of x as 1 over log to the base x of a. So they interchange and you can get reciprocal of logarithmic function. So we are going to use this property now to solve the given equation. Do you see that? It is a very important property. So the given equation can now be written as, it is 3 over log of 2x, that could be written as 3 times, so 1 over log to the base x of 2. Do you see that? So we use this property. Plus 2 times log to the base x of 3 equals to 1. So now we have logarithms with the same base, and we can now perform all the rules which you have learned for logarithms. So now we could write this as log to the base x of 2 to the power of 3 plus log to the base x of 3 square equals to 1, or log to the base x of 2 to the power of 3 is 8 plus log to the base x of 3 square is 9 equals to 1. We can multiply them. Log to the base x of 8 times 9 equals to 1, and that gives you log to the base x of 72 equals to 1. So what is x equals to? Right? 72 is equal to x to the power of 1, so x is 72. Right? So that is how we can solve this particular equation. So for x equals to 72, we'll get 3 over log to the base 2 of x plus 2 over log to the base of 3x as 1. So I hope you find this series interesting. We gave you kind of a review of solving logarithmic equation or evaluating logarithms. I'd like you to now look into the application questions based on logarithms to prepare yourself for this unit. Feel free to share your comments and views. If you like and subscribe, that'll be great. Thank you and all the best.